All right, in this question, we're looking to understand radioactive half-life. So we're gonna do two parts to this. First, we're understanding that there's different nucleotides. Here, they have different half-lives. Now it tells you how much there is of each one. We're not gonna do values in this question, but it's helpful to know that they all start with the same amount. So we can kind of think about that as we're going through. And so different nucleotides have different half-lives. And so the first thing we're going to do is compare their initial radioactivity. How radioactive are they? How quickly do they decompose? And so we see a comparison of days to years to days to years. So this days is faster. So we're going to say this one's the highest, then second highest. Then we're going to go to years. Now, how much to get to 1/16? So half-life. So half-life is something that the amount lost decreases. We saw this in class, right? So the comparison I like to use is if I'm buying a pair of jeans and it's 50% off and then an additional 50% off, what percentage are you paying for those pants? It's not zero, right? It's not 50 off and then the other 50 makes it 0%. So they're free. They're going to be 75% off, right? 50% off, and then 50% of the remaining 50%, which is 25%. So 75% off. Half-life's the same type of thing, where in the first half-life, we use half. So if we started with 10, in the first half-life, we go to 5. Now, in the second half-life, we then take half of that. So we go to 2.5. So we go to a half, and then we go to a fourth, and then we go to an eighth, and then to a 16th, and then to a 32nd. And so the next part of the question is, and this will change on each one, is how long to get to a certain amount. And this one is 16th. So it's 1, 2, 3, 4 half-life. So I'm going to multiply this number by 4 to figure out how many days or years or minutes it takes to get to 1/16 of the starting point. So let's do 45 times 4, and we'll work through these. So it doesn't have a specific number of digits, but it does like the period after. So let's check this. There we go. Okay, so understanding half-life. First, how fast does it happen? Minutes is faster than days, than years. And then what does a half-life look like? How much value do we have after 4 half-lives, 5 half-lives, 6 half-lives?